Bismillahirrahmanirrahim. Assalamu alaikum, dear students. You are watching Study with Sheraz, and in today's lecture, we are going to talk about the density of elements and its trends in the periodic table. We have started the periodicity of the elements in the periodic table, and this is the first lecture about the periodicity, in which we are going to discuss about the density of the elements. So first of all, we must have an idea that what is density, what is the unit of density, and what does it mean when we come to talk about the density of the elements. So first of all, density, as you people know, that the simplest definition of the density is that it's the ratio of mass per unit volume. That's the ratio of the atomic mass or the atomic weight of the atom of the element to the volume of the element or the size of the element. And if we talk about the unit of the density, that's gram per cubic centimeter. That is the simple unit of the density. So the important is that what is the variation in the periodic table? If we talk about the variation, first of all, we will talk about the variation in the period, then we will talk about the variation in the group. So variation in period, from left to right, first the density increases, then it decreases. It's basically the double trend in a period. At start, when we move from left to right, the value of density first increases, becomes maximum in the middle of the period, and then starts decreasing toward the end of period. Why does it happens? As you people know that the size of atom decreases from left to right, but the decrease in size is not regular. The size of atom first decreases from left to right, goes up to the middle. In the middle of the period, the size of the element is minimum, and then it starts gradually increasing toward the end of the period. Why does it happen? It is because when we move from left to right, the nuclear charge increases. So the volume or the size of the atom goes on decreases. But from middle to the end of the period, the number of electron goes on increasing in the valence shell. So because of the increase in the number of valence shell electrons, there occurs the repulsion between the valence electron. So the size of atom gradually starts increasing toward the end of the period. And because of the increase in the size from middle toward the end of the period, the value of density starts decreasing towards the end of the period. So this is because of the increase in size from middle to the end of the period. And if we talk about the density values in all the periods, so alkali metals lie at the minimum of the density. It just means that the alkali metals have lowest density in any of the period, because the alkali metals have greatest size in their respective period, so their density is minimum. Next, we talk about the variation in the group. So the density increases from top to bottom. As we know that from top to bottom, the size of atom goes on increasing. But why the density is increasing still with the increase in size from top to bottom? The reason is that from going top to bottom, not only the size of the atom is increasing, but the atomic weight or the weight of the nucleus is also increasing because of the increase in the number of protons and neutrons. So with the increase in the mass or the weight of the nucleus, the density still increases besides the increase in the number of shells or the increase in the size from top to bottom. As you people know that density is directly proportional to weight. So from top to bottom, weight increases. So despite the increase in the size, weight has a much pronounced effect on the density, and so the density of atoms or density of element goes on increasing from top to bottom. Here are given some factors that affect the value of density in the periodic table. The two factors are the weight of the nucleus and the size or the volume of the atom. But apart from these factors, there are some other factors that affect the value of the density. So first factor is the physical state of the elements. As you people know that the physical state means it whether the element is a gas or it is a liquid or is it a solid. So the size of the atom is not only its inherent property, but is also affected by the physical state. So physical state of the atoms also affect the size of atom, and it does affect the value of the density of the elements. The second factor which affects the density is the packing efficiency in solid crystals. You people know that different crystal systems have different arrangement of the particles, and that arrangement affects the size of the atom. So the density of atom or the density of elements is also affected by the crystal systems in the solid state. The third factor is the allotropic form. So as you people know that there are different allotropes of the sulfur, like the monoclinic, like the plastic sulfur, like the amorphous sulfur. So different allotropic forms have different crystalline systems or crystal systems. So this point is much related to the second point. As different allotropic forms have different crystal systems, so they have different sizes of the same atoms of the element in different crystalline forms. The fourth factor is the temperature. As you people know that temperature also affects the arrangement of atoms, and with the increase in the temperature, solids goes on expanding, liquids expand, gases expand. So temperature changes can also affect the size of the atom and can also affect the value of the density. The fifth factor is the magnitude of interatomic forces. If the atomic forces or the interionic forces are stronger, the ions or the atoms come close together, their size decreases to some extent and their density increases. And the last one is the atomicity of the molecules. As you people know that if we talk about the atomicity, that is O2, O3. Atomicity is basically the number of atoms present in a molecule. So here, same element is present in two different forms. It is O2, O3. The number of atoms is different in both these forms. So the size of atoms would be different in both these forms, and thus the density of the element would be different in both these molecules. So these are all the factors that affect the density of the elements. So this was all about the density of the elements and its variation in the periodic table. If you have any question, you can post your questions in our comment section. We would meet in the next video. Up till Allah Hafiz.